Here is the next example. In this example, he's asking about find the ix by using nodal analysis. He also chose this center node at the center as a reference node. Probably he chose that as a reference node because probably that is the, in that circuit, probably that's the node where it is grounded, or he wants to trick us and solve it by using the supernodal analysis. Okay, so what I'm going to do, step one, I'm going to choose all the nodes and node voltages. So I'm going to choose this as VA, VB, VC, and VD. Am I missing any other node? I don't think I'm not missing anything, so V reference is there. Okay, now do we need to apply KCL at VA? No, because as long as there is a voltage source between VA and reference node, don't need to apply KCL. Okay, I'm repeating that again. If there is a voltage source between unknown voltage node, so here is my unknown voltage node and the reference node. Here is the reference, here is unknown node voltage, here is reference. Then we don't need to apply KCL. Unknown node voltage equal to the source voltage, so VA equal to 150. So one thing is known. Now VB, do we need to apply KCL? Yes, at VB apply KCL because there is no voltage source between VB and reference. So apply KCL. I'm choosing every current is going out. I1, I2, I3 equal to 0. So I1 plus I2 plus I3 equal to 0. I1 equal to 10 ampere. I2 is nothing but VB over 25. And I3 is nothing but VB minus VC over 10 equal to 0. I'm going to simplify this. So after simplifying this equation, the equation is going to be 7VB minus 5VC equal to negative 500. That's my second equation. Now at VC apply KCL. Okay, but when you look at VC, there is a voltage source between VC and VD, as I told you in the previous example. So here is the definition. If there is a voltage source between two unknown voltage nodes, then solve it by using supernodal analysis. So what we need to do here, we need to apply a supernode equation. So supernodal equation is nothing but, I'm going to write currents at both nodes, I1, I2, I3, I4, I5, I6. Okay, so it's going to be apply KCL at VC and VD. Okay, at VC I have I1 plus I2 plus I3 plus VD I have I4 plus I5 plus I6 equal to 0. So I can clearly see I can cancel out I3 and I4. So I1 is nothing but VC minus VB over 10 plus I2 is nothing but VC over 20 plus I5 is nothing but negative 5. I6 is nothing but VD minus VA over 12.5 equal to 0. That's VD, don't confuse with VB. Okay, now when you look at the supernode VC and VD, you end up with two equations. One is very long one, very large one like this, and another one is small one. That small one is, so if you look at these three, okay, these two nodes, VD minus VC equal to 100, VD minus VC equal to 100. This is my fourth equation. That's third. This is my fourth equation. So you have four unknowns, four equations. Solve for VB. Once you find the VB, you can find IX. So let me simplify equation 3 of. So when I simplify this equation 3, to simplify it, I'm multiplying with 50. So I end up with the 5 VC minus 5 VB plus 2.5 VC minus 250 plus 4 VD minus 4 VA equal to 0. We know that equation 1 is VA equal to 100, and from equation 4 I have VD equal to 100 plus VC. So I replaced VD here and VA there, and the final simplified equation is I end up with 11.5 VC minus 5 VB equal to 250. Now I have equation 2 here, which is 7 VB minus 5 VC. So minus 5 VC plus 7 VB equal to minus 500. Now I have two unknowns, two equations. Now solve for, our goal is finding Ix, so solve for VB. So to solve for VB, what I'm going to do, I'm going to multiply this with 11.5. I'm going to multiply this with 5. So 5 times 11.5 VC minus 25 VB equal to 250 times 5, which is 1250. Now negative 5 times 11.5 VC plus 7 times, which is 80.5 equal to minus 5750. Okay, I'm adding these two equations. When I add them, these two are going to get cancelled out. By the way, I missed VB there. So 80.5 minus 25 VB, which is 55.5 VB equal to 4500. So VB equal to 4500 divided by 55.5. That value is 81.08 volt. Once I have VB, I can find Ix equal to 0 minus VB over, what is that resistance there? That resistance is 25. So 0 minus VB over 25. So minus 81.08 over 25. So divided by 25, that value is minus 3.24 ampere. Okay. So we found the required quantity. So with this, at least I solved 4 or 5 examples in the supernodal analysis. I'll stop it here. My future videos are going to be based on the mesh analysis. If you have more questions, please let me know. I can make more videos. Let me know in the comments. Thank you.